Hi, and welcome to the final section of this course, Reactive Programming. In this section, we'll show how Kotlin, RxJava, and Android play nicely together. And we'll use Reactive Java mostly for async execution of database and network calls. And when using RxJava for multi-threaded programming, we can avoid using callbacks and dealing with threads at a low level. And we can also use RxJava for functional programming, like for when transforming or mapping streams from one type to another. And this is all what we're going to learn in this section. RxJava, repositories, and API. And in this video, we'll learn how to add Reactive Java to our project and how retrofit and Realm can be used with Reactive Java. And it is assumed that you have at least basic knowledge of RxJava. And if you're completely new to reactive programming, it would be good to browse through the wiki page of Reactive Java. And the wiki has a good introduction and a couple of simple examples. And you can find this wiki on RxJava GitHub website. And since we already have working code for the app that used coroutines, we now only need to change those parts that used coroutines. And in Git, we created a new branch so we can have two versions of our app side by side. So the new branch is called RxJava. And to use RxJava in our project, we need to add it first to the build Gradle file. And these are two lines that add the reactive library, and RxAndroid is the extensions for using Android schedulers. And we also need to use retrofit adapters, and we can get rid of the coroutines because we no longer use them. And this is Reactive Java version 1. In the meantime, version 2 was released, which has some breaking changes from version 1. And we chose version 1 because Realm currently only supports this version. And you can of course use version 2, but then you have to create your own observable converters for Realm. And we'll start with the lowest level, and that's our retrofit API and repositories. So open up the News API interface, and here retrofit can convert automatically response objects to observables, and the only thing that is needed is to wrap the response model classes as generic parameter observable class. And this is what our function returns. And that's all you need to do concerning retrofit. Next, we have the repository interface. And previously we had suspend functions on all functions that could take longer to execute. And now those functions return observable. So we can handle async operations with RxJava. And great thing is that Realm already has support for RxJava, so only thing that is needed is to write one extension method that will convert any Realm operation to observable. And in RxJava there are several ways to create an observable. There are functions to create a stream from an iterable interface, to create a single value only, and also an empty observable. And there is also a function for manual creating of observables, and this one gives you full control over the reactive stream. And this is great for adapting callback style APIs to reactive streams, and that is the create function on the observable class. And this one accepts an emitter object, and with this emitter object you then control the reactive stream by calling its onNext, onCompleted, or error methods. And that's exactly what we do here. We start a transaction, a Realm transaction, and pass callbacks to it. You can see that we passed 3 callbacks. These are these 3 lambdas. And in callbacks, we control the emitter and produce value. And since we're not producing any real values, we just pass a unit instance on the onNext call and then immediately call onCompleted. And if something goes wrong inside the transaction, this callback will be executed, and then on the emitter we call onError. And back in the repository base, you can see that Realm query has a method as observable, and this is what we use to convert the Realm queries to observable stream. And you can see here that we filter only loaded objects from the Realm database. And with this first call, we instruct Realm that it should not emit results after we get the first one. So if a change happens in the underlying query, we'll only get the initial result. And for example, in this delete method, you can see how we use the extension function we created. It accepts a receiver function as an argument, So inside this receiver function, we can execute multiple operations on realm, and they will all be executed under a transaction and will be returned as observable. And the rest of the class uses the same principle. It either uses the asObservable calls or uses this extension function that we created. The logic, of course, remains the same as it was in the coroutine section. And now that the lowest levels of our app use observables instead of coroutines,